Relational databases became the foundation of modern data systems after they were popularized in the 1970s, mainly through work done at IBM, and later commercialized by companies like Oracle. Over time, this model became the standard for structured data storage. The most well-known relational databases include MySQL, PostgreSQL, and Oracle Database, along with Microsoft SQL Server in enterprise environments. These systems all use SQL, which stands for Structured Query Language, to manage data. With SQL, you can easily perform operations like select to read data, insert to add new data, and update to modify existing data. The key idea here is that data is stored in tables made of rows and columns, and everything follows a strict structure. This makes relational databases extremely reliable and consistent, which is why they are widely used in banking systems, e-commerce platforms, and any application where accuracy and structure are very important. But as technology grew and the internet expanded, a new challenge appeared. Not all data fits neatly into tables. Some data is unstructured, constantly changing, or extremely large in scale. This is where NoSQL databases came into the picture. Companies like Google, Facebook, and Amazon needed systems that could handle massive amounts of flexible data without strict rules. NoSQL databases such as MongoDB, Firebase, and Cassandra solved this problem by removing the rigid table structure. Instead, they allowed data to be stored in formats like JSON-like documents or key-value pairs. This makes them much more flexible and scalable compared to traditional relational systems. NoSQL databases are widely used in real-time applications, large-scale systems, and apps where data structure may change frequently. However, this flexibility comes at a cost because they are generally less strict with consistency compared to relational databases. Inside NoSQL, there are several important categories, each designed for a specific type of problem. The simplest is the key-value database, with Redis being the most popular example. In this system, data is stored as simple pairs, like a key pointing directly to a value such as user123 to Ali. There is no complex structure, which makes it extremely fast and efficient. This is why key-value databases are often used for caching, session storage, and real-time systems where speed is critical. You can think of it like a dictionary where every key has a direct meaning or value. Another important type is document databases. MongoDB is the most well-known example in this category. Instead of storing data in rows and columns, it stores complete documents, usually in JSON format. Each document can have a different structure, which makes it ideal for flexible applications. This type of database is commonly used in web applications, APIs, and dynamic systems where data does not always follow a fixed pattern. You can think of each record as a complete object that contains all related information together. Graph databases take a completely different approach. Instead of focusing on tables or documents, they focus on relationships between data. Neo4j is one of the most popular graph databases. In this system, data is stored as nodes, which represent entities like people, and edges, which represent relationships between them. For example, a simple connection could be Ali is friends with Ahmed. This structure makes graph databases extremely powerful for applications where relationships matter more than individual data points. They are widely used in social networks, recommendation systems, and fraud detection systems. You can think of them as networks of connections rather than simple stored records. Time series databases are designed for data that changes over time. Examples include InfluxDB and Prometheus. In these systems, data is stored with a time and value format, such as temperature readings or stock prices over time. For example, 10 o'clock might show 20 degrees Celsius and 10:01 might show 21 degrees Celsius. These databases are optimized for tracking continuous data changes. They are commonly used in monitoring systems, IoT devices, sensors, and financial markets. The main idea is to efficiently store and analyze data that evolves over time. Finally, the newest and most important category in modern computing is vector databases. Examples include Pinecone and Weaviate. These databases are designed for artificial intelligence systems. Instead of storing normal text or structured data, they store embeddings, which are numerical representations of meaning. This allows machines to understand similarity between different pieces of data. For example, two sentences with different words but similar meanings can still be matched. This technology powers AI applications like semantic search, recommendation systems, and large language models. Vector databases are becoming extremely important as AI continues to grow and require smarter ways to store and retrieve information.